Good morning, one and all. My name is Sudhakar. I'm teaching about the basic manufacturing technology. In that, we are discussing about the lathe machines. So, before going to discussing today's class, we can recall what we have learned so far. Yesterday's session, what we have learned. That we keep diving. Okay? So, in yesterday's class, we are going to discuss about the production rates, types of production rates. Right? In the types of production rate, first of all, we have discussed about the what is production rate, right? So, what is production rate? It is the modification of user rate. Some of the modifications have been done on the user rate, so we are getting that production. Okay? And next, why we are modifying that user rate? To meet the production demands, to meet customer demands. Some changes have been needed in the engine, right? To meet the production demand, we are doing some modifications to the that is called as the production rate. So, by in the production rate, we are getting batch and mass production. So, I already told you that mass is the similar product, but the number of products are high. That means that similar operations are done on the production rate. Okay? So, this can be achieved by some modifications to it. Okay? And complicated jobs, the jobs which are not manufactured on the user lathe, not doing any machining operation on the lathe, that type of machines, type of operations have been done on the production rate. Okay? And the productivity increases. Why the productivity increases? Because setting time is reduced. Setting time is reduced based on the productivity. Okay? So this is all about the production rate. Okay? Production rate is the modification of production rate to meet the demands. By using production rate, we are reducing mass and production, and complicated jobs are handled by the production rate, and complicated jobs handled by production rate, and the productivity is more compared to the okay? So this is all about the production. In the production rate, the various types of production rate, right? Okay, capstan rate, capstan rate, that also called as a production rate, including the production rates. We are having different types of production rates: semi-automatic, automatic lathe, semi-automatic lathe, cartwright lathe, capstan lathe, NC lathe machine, and the CNC lathe. In that we have discussed so far capstan, semi-automatic lathe, automatic lathe, NC lathe, and CNC lathe. In automatic lathe, the manpower is less, and one man can operate more than two machines. Okay? Only loading and unloading can be done with a semi-automatic machine. Rest of the works are all done by the machine itself. In NC machine, there is a programmable tape called as a punching tape. The punching tape loaded on the machine. The machine read the instructions, follow the instruction, and do the needfuls. By the instructions, the actuators are actuated, and the actuators are running some mechanism in the machines. So based on that mechanism, the machine is doing machinery operation. This is the totally NC machine. And then the CNC machine. It is similar to the NC machine, but the change is only here. The function can be replaced with the computer program, right? meeting the customer demands. Okay, so we can easily change the program in the configuration. But in the LC machine, we have to change the entire tape of the machine, because we don't do any modifications while doing the operation. But in the computer numerical control, we can easily modify the programs while doing the operation. This is the major difference between the LC machines and CNC machines. And about the CNC machines and CNC machines, we have a separate subject in our further studies, that is in our final year, third year subjects. We have a separate subject in that final year. Okay, that in that we are clearly discussing about that machines. Okay, this is the discussion we have learned in the yesterday session, right? So what is production lathe and types of production lathes, right? Now we are moving to the today's session, that is turret lathe. To eliminate the amount of skilled labor, okay, what is the main purpose of turret lathe that we have discussed now? To eliminate the amount of skilled labor. Here we don't need any skilled labor. Okay, just a trained person is enough to do the operations and to operate the machine. Okay, the turret lathe we are not we don't need any skilled labor. Okay, that's the point here, to eliminate the amount of skilled labor and adapted to quantity production work. Turret lathe is adapted to quantity production work. So quantity means number of products that can be manufactured with less time. So turret lathe is adapted to quantity production work. We can manufacture and we can produce number of products with less time. That can be achieved by the turret lathe, and also eliminates the amount of skilled labor. And it can hold a number of cutting tools at a time, as I have told already this point, and we have learned so far now. The turret lathe is having number of tools operate at a time. It is having some tool magazine that can be in the shape of hexagonal or some shapes. In that shape, number of tools are folded. Okay, so it can hold a number of cutting tools at a time and operates whenever the particular tool is needed. That particular tool is come and doing the machining operation and going to that place and rest in that place. Okay, we have discussed also in the work holding devices what are the tools are in the turret lathe, how the tool is fitted in the turret tool magazine. That will be that has discussed in our sessions. Okay, tools may be set up in the turret head in sequence. The tools may be set up in the turret head in sequence. Sequential orderly, they are fixed. Okay, that means sequence means suppose if we want to do in turning, boring, drilling, and reaming operations on a particular workpiece, right? So we have to arrange the tool in the sequence of operation order, right? That is, first we are not doing drilling operation. First we are going to do the turning operation. Okay. First we are doing the turning operation. So that's why in the first place the turning tool, the cutting tool is maybe placed. The cutting tool is placed, right? Now, next we are doing the drilling operation, right? For drilling operation, we are providing a drill bit on the tool magazine, right? After that, the drilling operation, the drilling means producing the holes, right? And after that, we are providing a boring tool. If we are producing the hole should not get its dimensions, right? So for that, we are providing boring tool, the tool magazine. turning operation, each tool is placed, we can easily tell that reaming tool, right? Reaming tool. So reaming is the final finishing operation. The final finishing operation of the hole. So this is the sequence of operation we have followed while doing the some machining operations, right? And if we want to produce some threads in the machine, if we are going to produce the threads on the workpiece, internal threads on the workpiece, we are now going to do the tapping operation. So this can be done by after the reaming operation, right? So reaming operation, after that we are doing tapping, that means internal threads. So this is the sequence we have been followed in our manufacturing process. First is turning operation, drilling, boring, reaming, and tapping operations. So based on these operations, the tools may be set up in the turret again sequence. Okay, and feed movement of each tool is regulated by stops and feed trips. The feed movement of each tool is, so we are having different tools in our tool bag, right? So the feed movement of each tool is regulated by some of the stops and feed trips. These are provided on the machine itself, so that they are regulated the each tool. Okay, so stops and feed trips are control the feed movement of each tool. So this is the turret lathe we have showed in this figure. Okay, so A is the headstock, B spindle, C pilot bar, D tool post, E rear tool post, F cross slide, G intermediate saddle, H turret, E I turret clamp lever, J saddle hooking lever, K star handle for turret operation, L turret apron, M turret saddle, N intermediate saddle apron, and O feed K-pop. So these are the parts in the turret lathe that we are observed in our turret lathe diagram. Okay. Here the important thing we have to observe here is that is K star handle for turret operation. If we are engaged in a particular tool, we have to operate that K star handle for turning operation, and I turret clamp lever that should be engaged by that lever. Okay. J saddle looking lever, and cross H is the turret. Okay. So in this turret we are fixing number of tools. Okay. Number of tools that is based on their slots. Okay. So that can be operated by I and K. Okay. That can be operated by I and K. If we are rotating this K lever, we are taking the particular movement of the tool. So saddle bolted to the bed of the lathe. Saddle bolted to the bed of the lathe. Also, it is called as a saddle type lathe. Here, saddle bolted to the bed of the lathe machine, and it is also called as a saddle type lathe. It is heavier in construction. Saddle type lathe is heavier in construction. Initial cost is considerably higher. Saddle is bolted to the bed of the lathe, also called as saddle type lathe. It is heavier in construction and initial cost is considerably higher. This is the type of lathe that we have observed in the diagram. So these are the tool max here. Directly 1, 2, 3, 4, 5, 6. This is the hexagonal tool max, and that number of tools are fixed. Okay, turning tool, cutting tool, and that number of tools are fixed. So if a particular operation has to be done, that will be engaged to this workpiece, and the rest of the tools are remaining tools are in rest position. If we want to do this operation with this tool, it will be engaged by rotating this tool magnet. So by doing this operation, by doing this tool magnet, we are reducing the time. We are reducing the time. These are also some of the examples of turrets. So here, features of turret lathe. Hexagonal turret replaces the tailstock. The turret is a tool holder on which six tools can be mounted, can be rotated about a vertical axis. Entire unit can be moved longitudinally. It is mounted on the saddle or carriage on bridges. It is provided with indexing mechanism. Indexing mechanism will be rotate the present tool away and bring another tool in position for next operation. One by one we will discuss these points. Hexagonal turret replaces the tailstock. Here the turret lathe, how it can be look like looks that will be discussing now. Here the turret lathe, where is the hexagonal turret is placed? The place of tailstock. Here there is no tailstock up here. Here hexagonal turret is appeared for us. Okay. Here the turret is a tool holder. What is the turret means? It is a tool holder. In that tool holder, we are fixing number of tools. In the diagram, we are observed hexagonal turret. So hexagonal turret means we have fixed six tools. We have fixed six tools. So that is called as a hexagonal turret, on which six tools can be mounted. The turret, I have already told you that six tools can be mounted on the hexagonal turret, and it can be rotated about a vertical axis. That hexagonal turret can be rotated about a vertical axis. Why it can be rotated vertical axis? If a particular tool has to do the operation, has to do the need operation, that should be engaged with the cutting tool. That should be engaged to the workpiece. That's why the vertical axis can be rotated to the hexagonal turret can be rotated about a vertical axis, and the entire unit can be moved longitudinally. After engaging with the workpiece, the cutting tool has to be moved longitudinally. But then only we can do the machining operation, right? Otherwise, we cannot do any machining operation. That's why to change the tool position, it can be rotated vertical axis, and to do the manufacturing operation, it can be moved longitudinally. It is mounted on the saddle or carriage on bedways. So the turret lathe, where it is mounted on the saddle or carriage on bedways. It is provided with indexing mechanism. Turret lathe is provided with indexing mechanism. Why this indexing mechanism? Because indexing mechanism will rotate the present tool away and bring another tool in position for the next operation. Okay. Indexing mechanism I have already told you in the previous missions. That will rotate the present tool away and bring another tool in position for next operation. Right? If we are doing the drilling operation at present now, after that we are going to do the boring operation. So for that reason, we are operating this indexing mechanism. This indexing mechanism will rotate the present tool away. Exactly rotate with some angle. Indexing means it is rotated with angles. Okay, with that angles, right? If the angle between the drilling tool and boring tool is, if it is a hexagonal turret, exactly it should be 45 degrees each other. So with the 45 degrees, the indexing mechanism is rotated. With the 45 degrees rotation, the drilling tool replaced with the pouring tool, right? So that's why this mechanism is useful for us. Okay, these are the features of turret lathe. Here, the hexagonal turret is replaced with feedstock, and it is a tool holder on which six tools can be mounted, and it can be rotated about the vertical axis. Entire unit can be mounted longitudinally. It is mounted on the saddle or carriage and replaced. It is provided with indexing mechanism. Indexing mechanism will rotate the present tool away and bring another tool in position for next operation. So we know some of the advantages of the turret lathe, right? It should be now we have to observe now different machining operations, right? Drilling operations, reaming operation, boring can be performed in a single set by a hexagonal turret. I have told you with some examples also. Drilling, reaming, boring can be performed in a single setting by a hexagonal turret. So in every tool, that tool mentioned in hexagonal turret, we have hexagonal drilling, reaming, and boring tools. So by rotating the mechanism, these tools can be operated. Okay, and also it reduces the settling time, tool settling time. Here we don't have to change the tools every time. Once we have fixed the tools, that will be useful for us. Only the indexing is helpful for us. So that's why here the reducing the setting time and the production time is also reduced. Production time reduced means number of products produced at a less time. And here skilled operator are also not essential in this machining operation. Skilled operator are not essential, and it is used for large scale production of identical parts. Okay, so these are the advantages of turret lathe. Different operations, machine operations, drilling, reaming, boring can be performed in a single setting by a hexagonal turret, and considerably reduces the tool setting time, minimized production time, and single operator, uh, not skilled operator, not essential, large production of identical parts. So these are the main points of the turret lathe. Okay, and next we are moving. Now we are going to capstan lathe. So observe the diagram. What are the parts in capstan lathe? Single speed selector here, forward and reverse selector here. This is the stop rod, but it stops the given to carriage movement. Feed shaft, longitudinal feed lever, carriage manual, cross slide manual, cross feed lever, feed selectors, the turn style, that's the way, square turret, hexagonal turret, ram, turret stops. So these are the stops observed in the capstan. So now we are going to discuss about the capstan lathe. It is small or medium sized capstan lathe, and it carries an hexagonal turret on a frame. Similar to turret lathe, it also carries a turret. It is lighter in construction compared to turret lathe, which is lighter in construction, that is goes into construction. And it is ram flies longitudinally on saddle. Ram flies longitudinally saddle. Relatively short scope of the tool head. That's the way relatively short scope of the tool head. So let's say and I usually carries 6 seconds. Extended usually carries 6 seconds. Rapid presentation is very fastly indexing is done because here we are dealing with the automatic indexing. Okay? So this is all about the external medium side of medium side function. This carries the external current lateral construction. The branch slides wrongly to the other side. So on the run, okay, on the run, external current is there. So that the branch moves wrongly to the moves to the okay. So external current on the run. So changing the tone, the external current is moving vertically. Okay, for longitudinal movement, here once expression deriving both of these called so for longitudinal movement of the two, hand slides longitudinal side. Okay, relatively sharp stroke of the two head, automatic protection machines with automatic protection. The tools change automatically. Usually carries generally 6 years. So the code changing by rapidly. So here we are observing one point that similar to correctly idea 6 years, but only the code change here is the RAM. On the RAM, on the RAM correct is placed. Okay? But longitudinal movement, the RAM is sides on the side. Okay. But compared to directly, it is lighter construction. Real side operations, but in this automatic there, but this tools are changed. But tools are compared to directly, 6 tools. Right? So, picture about the capstan. Yeah, square array. Square array means we are having only here we have fixed 4 tools. Right? 4 tools we have fixed 4. That's why it is called square post. It is a air tool post. This side also we have fixed some of the tools. And this entire thing we know that slide and here hexagonal turret is there. Okay. So this is the RAM. Don't see this RAM of the current weight motion. This is the RAM. On this RAM, hexagonal turret is placed. So to rotating to changing this tool, there is an automatic mechanism there. Based on the operation, automatic is done. For completing an operation and the next operation is done automatically. And changing the tool design. Okay. But for longitudinal movement, this RAM is the slides on the side. So this is slide. So this also we are having schools, therefore post, therefore school line correct just total post check the and this one now we are going to discussing about the difference between direct and indirect. So, direct. So here the picture shows direct of direct. So direct of direct direct moves with the saddle all times. Here the director red is moving on the saddle, right? So shows the direct and the direct moves with saddle all. See the saddle and here we are on the it's direct moves from the saddle all times. So this is a very important point. So the current is the tool holding and rotating part which is carried on the mobile side. Here in the current line, the current is the tool holding and rotating part which is carried on the mobile side. The current is the tool holding and rotating part which is carried on the mobile side. Here the current moves the side. Where has a capstan lathe, the current is on the man. The man is moving, the current is moving. That's why we have discussed the previous slide. The current is the holding and rotating, which is carried on the movable side. Here, the current, observe this point is a very important difference. The current is on the side, movable side. If you want to move the current, you have to move the side. So, in the hypothetical, the current moves on the side. So, in the picture itself, we have observed the current is on the side. The current means saddle, the constant load here is on the constant load. Constant load is on the ram. The rest is separately held on the ram. When we need to do this, we have to do it separately. But here, the saddle itself moving the saddle. Here, if we need this direct movement, we have to move this ram. By moving the ram, the platform, that means on that it is moving. But in this saddle directly moving on the footprints of the leg. Okay? So these are the differences between direct and indirect. We have observed so many differences that the similar points also existed before. In that, so far we have noted that both are having turrets. Generally, the turret is having spools. Okay, and the turret is rotated vertically or the vertical axis, and the long-term movement also there for the axis. And the other differences also we have observed that the turret of turret is cascading around here. Turret of the turret is zero construction because it is not painting or not getting any reflections by the reflector. These are the zero construction. No portions are no external line forces are not affected. So it is why because the double construction is rigid construction. Next, capstan loop band. If it is non-rigid construction, capstan band is non-rigid construction and it is bending tendency. If it is not in non-rigid construction, forces while doing the operation can affect the turret of the capstan lathe. Capstan lathe RAM. If the RAM is affected, automatically the turret lathe is turret also affected because the turret is fixed on the RAM, right? So bending tendency is there in capstan lathe because non-rigid construction. Deflection possibility is any. If it is non-rigid construction, some of the difficulties happen. That is bending tendency is there, deflection possibility is there, down to vibration, and maybe going to the vibrations also. Okay. It is affected with the vibrations. Okay. So these are the main other differences. Extended current rate of vibrating region. So there is no reflections or any vibrations while doing the operation, but extended RAM is not. So these bending tendency is there, deflection possibility is there, prone to vibration. So these are the difficulties come to the capstan wave. Right? Okay. But the current of current wave is in construction. Okay. So current wave is suitable for larger, heavier checking works. Capstan wave is suitable for power work. Okay. So these are also another differences. The current wave is suitable for larger and heavier work, so heavier checking works. Using work capstan wave is used for small. We have discussed in the capstan wave itself tells that it is used for light and light machine works. So that's why capstan waves are suitable for power work. The current wave is suitable for larger and heavier checking works. Current wave, mind feeding these areas. Okay. That means here we have to do the feeding, right? Manually. So that's why it is called as a laborious feeding. Mind feeding these laborious right? And itself. And generally equipped with the power feeding, the turret and dead stops and turret that have to be fixed into position by hand. Okay. So at this point, the turret and dead stops on turret blades have to be indexed into position by hand. That means if we want to control the longitudinal movement of the tool, that should be operated by manually because here the stops are provided on the tablet blade. So by doing so, the tablet long-term movement will be controlled. Okay, that is the one point. So that's why it is called as by hand control. Now, the indexing also done by the indexing. Indexing means we have already discussed about this indexing. That indexing means we have to change the tool positions, tool cutting tool position, right? After doing the drilling or operation, next we have to show that boring tool, right? So that's change. The changing of the tool, the changing of the rotation of the turret should be done by the hand, not by the automatically they are not changed. Okay, so these are the points. The turret and it stops on turret blades have to be indexed into position by hand. Whereas in capstan blade, so RAM can be moved rapidly. Here, the RAM can be moved rapidly, and it is mainly for small articles. And it is light and fast. Okay. The turret blade and feeding is the various turret and capstan stops can be done by the in this RAM can be moved rapidly. longitudinal movement, it can be more rapid position to other position. So if the RAM move rapidly, we are easily getting the longitudinal movement, easily controlling the handy for can be handy for small articles. So maybe handy for small articles. And it is helpful for right and fast cuts. Capstan will be helpful for right and fast cuts. Right? So here the average index series is done by the hand itself, but the capstan index series is done by the automatically. Okay, and in average heavy works are heavy high work, heavy jobs and complicated jobs have been done. I think capstan based vehicle operations better mission construction there. Yes, strong jobs can be better, small jobs can be handled by the capstan. Here, the current capstan based the current views of the value. So, now on this slide, saddle. Put the round saddle on the saddle. The current is going. But in the current below, the current is on the saddle itself. If the saddle goes, the current is low. So, now can we recall what we have done yesterday and today? That will be summarized now. Here, various types of production grids are now. What are the production grids? Automatic grids, semi-automatic grids. Okay. Textile grids, private grids, policy grids, CNC grids. Capstone and other grids simplify batch of mass production. Capstone also we have discussed today that simplify batch of mass production. We have already discussed that batch means same number of objects, sorry, similar operations are going to be done on products. Once products are called as mass production, and mass production means different types of operation have been. Sorry, mass production means similar products, but we can produce in the large scale. Similar products, but we produce in the large quantity. That's why they are called as a mass production. And also we have discussed about the differences between the capsule and capillary. Let us summarize those are. In the capillary, we have having a connected same similar to capsule also. Capillary we also having a connected head and also so which are specified. And here the capillary is synthetic heavier machining works. Right? And it can hold the heavy machines. And what is capsule? outside, okay, can be the paint. So these are the differences between the capsule and the family. So based on this, we can do some discussions. Production rates are suitable for job production or batch production. We told that it is suitable for batch production. An industry is having a demand of different sizes of screws in terms of size. Which type of lathe you suggest? Okay. Observe this question. Industry is having a demand of different sizes, right? Different sizes of screws in terms of lakhs per annum. We are not the same size, mentioned different sizes. That means different batch production. So which type of lathe you suggest? Tell me which type of lathe you suggest? Special purpose lathe. Impellers of a multi-blade pump application, which type of lathe you suggest? Coping lathe is coping lathe. Impellers, coping lathe we have discussed that. If we want to produce some profiles, we are using a template. So based on the template, the manufacturing process has been done. The stylus is moving on that template. Template means predefined path. That predefined path, the stylus is traveled. Based on the travel, the workpiece is traveled on the workpiece. So we are getting that shape. So this means the called tab. GI parts are to be fed with one way, which type of thing is suitable. So threading gaps and that is suitable. Private life is suitable for precision jobs, heavy work is heavy work pieces. Heavy work pieces we have already discussed that. Okay. So these are the questions. Don't ask them now. Okay. So now concluded today. We have discussed about the tablet length and capsule length. We are providing so much time for this. So by this I can